Okay, so guys, I'm going to hand out to you guys the formula sheet that everybody is going to get on the final. I was told this morning that the formula sheet has a typo on it. This is already copied and stapled to the front of the final. So I'm going to show you what that is, and you can fix it on this one, and then we'll fix it on the one for the test itself. It's got a lot of stuff on it. So this is every single thing you could possibly imagine, okay? So I'm just saying, there's a lot of stuff on here. We may not need all of it. We'll certainly need some of it. But this is kind of, it's going to be fun. But I mean, you'll have this literal exact one on your final. Wait, that was a really weird noise, man. Like, I thought something was wrong, and so I was listening for it, and I was like, oh, okay. Okay. So look on down to, which one is it? The surface area and volume formulas. We're not even going to get to this today, but I want to fix it now. So if you go all the way down to where it says sphere, what we're going to do, it should be, it is 4/3, that's right. But it's the fact that it's not squared, it's supposed to be to the third power. So if you would, I'm going to use a pencil because that's what I have up here. So change this to a 3. And then for the hemisphere, it's the same thing. You're going to do the 3 there. And guys, we'll talk about all of these as they come. But for right now, it's just kind of correcting them enough. When you look at it, you'll go, oh, yeah, that was the mistake. I remember that now. What we're going to try to get to today is we're going to try to see if we can get through all the stuff from chapter 6. Is it okay if I take this off now? Fortunately, what we've got done on here is we have all of the types of questions that you could run into, and we're just going to do as much as we can. So I've got Tuesday on here because, guys, guess what day today is? It's Tuesday. So we're going to go through this and write as much of the stuff down as we can. If at any point in time there's a question, you're like, man, I have no idea what the heck you're talking about, let's talk. I mean, that's kind of the point of what we're doing here. I am intrigued as to how much of my talking is going to get picked up by this, but we'll see. Okay, guys, you ready for magic? Do you remember the polygon angle sum formula? If you don't, where is it? It is, in this case, the number of sides minus the minus 2 times 180 degrees. Because it's basically the number of triangles you can draw on the inside of a shape, and then all of those things added up. So this is going to be n minus 2 times 180 degrees. So that's the entire thing. Yeah, well, hold on. Which one are we looking at? This does have to be on here, right? There it is. Hey, look, it says right there, the polygon angle sum theorem, 180 times n minus 2. Exterior angles of a polygon always adds 2. Can you guys add something on this? Because I think it might be helpful. Say yes, because that makes it better for the show. What did I say? I can't wait. There's going to be a time in like 20 years that this is going to be up on YouTube. We'll come back and I'll be like, do you remember that day? We all remember that day. Yes, Robert. Okay, so here's what we're going to do. You're going to be YouTube famous. Just stop. I don't want to know any about the manifesto that's currently being written. So here's what we're going to do. What I want to make sure, this is going to get me in trouble because I can't stop those thoughts from actually coming out. Okay, underneath this, can you write one angle regular polygon? Well, here's what I mean. So regular polygon, we'll talk about in just a second, but a regular polygon is just a polygon where all the angles are the same, all the sides are the same, right? So a lot of times what they'll ask you to do is to find what is the measure of one angle as we do something like that. And so here, if we're going to use a formula to find one angle of a regular polygon and we know how many sides it has, we take the total sum, so that n minus 2 times 180, and we're going to want to divide that by n. because that's how many angles there will be. Doing all right? They may ask a question in one of these that says, find the measure of, there, actually, look at number 3. Find the measure of each interior angle of a regular decagon. So it's asking you for what is one angle, not what is all angles. And that's the part about it that I wanted to make sure we could talk about. Evan, you all right, man? Is it just not working well?
Wait, 180 times n minus 2 is to figure out what?
To figure out all of the angles.
Divided by n.
Divided by n tells you what one of them would be, as long as they're all equal. Now, guys, let's look at our first problem here. What type of shape is that? Hexagon, which means how many sides? 6. So if we've got a 6-sided figure and we want to solve for x and all the angle measures, if we're going to solve for x, what would we have to do first? Yeah, we got to find the sum, and then we got to add them all together and set them equal. So first, let's do the sum to make sure we have that. How would I find the sum of this? Somebody help me out. 6 minus 2 times 180, which is going to be 720 degrees. I'm almost positive I'm right. Can somebody check?
Oh, we added the 3 6 in.
It would. But in this case, we're talking about the inside. Yeah, 4 times 180. Okay. Now, we don't know that this is regular, so we do have to set up the total sum. Can I tell you what to do for something like this? No. I could write this out, but if I'm going to combine like terms of all of the things that we have on the inside here, how many x's are there? That one's nice. We can count the 6 x's pretty quickly. Now, I'm going to just add all of the constants, right? So we have -4. I'm going to put the negatives together first. -4, -3, and -8 together would make -15. Still with me? Okay. +2, +6, and +7 would make +15. So we combine them together. All of these angles together are 6x. Sydney, what's up? Your hand was up. What's going on? Not necessarily, because in the case of something like this, we can't trust the drawing because they didn't say that it was regular. If we knew that when we were looking at something like this, we could do that, then we'd be okay. But right now, since we're talking about the interior ones, one of them could be, like if this is 720 degrees, one of them could be 179 degrees and the other one could be 1. Yeah, they're not, but it looks like they could be. And so for right now, we just have to trust that we could do this for all. Okay, so I've got 6x for this one, and it is equal to 720, because that's the total sum that we have here using our formula. So if they add up to 720 and it's that, and I take both sides and divide them by 6, then I am going to get that one value for x is going to equal 120. Am I correct? Now, guys, I know that you can do this math. I'm going to try to do it relatively quickly. If x is 120, first off, I want you to know that if we're writing this on a final, I need you to understand that if I wrote the question, I would be lazy enough to make sure that I wouldn't have this many things you would have to write down. They're asking for all 6 of these angles. I wouldn't do a question like this because I want to be able to grade this relatively easy to find out what you have. Now, because it's on here, we're just going to do this. So this one's 122 because I added 2 to it. This one here adds 6 to it, so it's going to be 126. This one adds 7, so it's 127. Okay, so we have all the adding ones there. Now I'm going to subtract. If I take 4 off, that makes this one 116. If I take 8 off, that makes this one 112. And if I take 3 off, that makes this one 117. So those are the ones that we have, and they're all written on. It is a pain in the behind to grade tests like this, because if you guys make one mistake on there, I have to make a decision as to whether I like you or not. So if I'm going to give you the 5 points or not. I'm just kidding. I don't do that. If you make one mistake and you've done all the other math work right, I 100% give you 5 out of 5. I stop. Both of you raising your hands. You are. Do you want to go out into the hallway and take that test that you needed to make up today, or are you just going to do what you asked? Just so that you all know, that's all for posterity. Right there. You see it right there? Thank you. Okay, so here's what we're going to do. I'm not a hypocrite. I really don't do that. Anytime you make one mistake on a quiz and there's something that is this much work, I always give you a 5 out of 5. If it's something that's like back here, I have to take the point because that's too integral to all of this. If it really is just plugging it in, like some of you on tests have written things down and you copy the number wrong. Every other piece of work is fine. but like in a part all the way up here, you'd write down x plus x minus 6 instead of x minus 8. And every single thing else is correct. I generally am going to give you full credit for something. Okay. Now, we okay? What type of angles are all of these? Correct. Because it looks like a pin. Except for which? Yeah, 138's on the inside. Just weird that they did put that there. You know why? Because that's going to help us with this one here. And because they didn't, the only exterior angle they didn't give us is that one. So they gave us the 138 because that one's missing, which is kind of like, you know, you look at the clue and go, oh, wait, what did they do? So we know that the exterior adds up to 360. That's love. Now, we don't have this one yet, but can you guys tell me, for that exterior angle, how could we find it relatively quickly? What'd you do? You're right. What'd you do? Whoever said it, you said it. I'm sorry. I looked up because it was just a noise that was over there. So you said it's 42? Yeah. So if you do 180 minus 138, you're going to get 42 for that. Okay. We're going to do another similar thing that we did for the last one, which is add them all together and have it equal 360. So in this case, how many X's do I have? 1, 2, there's 4. Got to count them. Now, I'm going to do this though, because this is kind of nuts. I'm just going to do a little tick mark by each of these. So we got 4 X's. This is a little bit crazy for what we're going to have to do. It's 34. If you add
76.
Maha! Hold on. I'm actually going to write this one out.
I didn't add the 42. I didn't add the 42.
How dare you, sir? Okay. It's okay.
42, right here.
All I have to say, guys, this is what class is like every day. Okay, so you said it's 76 when I add all of them together. Okay, can I make a suggestion? Did we just find out how easy it is to make a mistake on this? So it just, well, nobody on this video knows that it's you, Daxon. I mean, come on. I'm just kidding. Robert, nobody knows that it's you. I was calling you in there because it was recorded on here, and then that would have been funny if I made fun of you for doing the thing. It wasn't a really good joke, but okay. So what I want you guys to do is on the test, just make sure if you've got this many things to add together, show the things that you're adding. Just write it quick so that if you show your work, you can look back and I can see what you've done. 76, I trust is right since 2 of you guys corrected him so vehemently. So 76 is fine. Let's solve for X and then we can be done with this business. What do we do next? Minus 76. So if we do that, we get that 4X is equal to 360 minus 76, which is going to be 294? 84. Thank you. This is why we have a calculator. What do we do on both sides now? Divide by 4, and X is equal to 71.
Yeah.
Good. Okay. Now here they only asked to solve for X. Wasn't that nice of them? So again, sum total of all of the exterior angles equals 360. Just solve for what we have.
Who are they?
They being the person that wrote this. This is, I believe, Miss Aguirre. The government, yes, they're the ones that did this. In terms of the final, I believe that the final has been a conglomeration of like, we've given so many different finals going back to like 10 years ago. And so even through COVID, we basically just went, yeah, I like that one. Oh, I like this one over here. I like that one. And they kind of went together for this. Okay. Measure of each interior angle of a regular decagon. First, can somebody tell me decagon? Yep. If you don't know that for the test, should you just guess or should you ask? Yeah, please, dear God, ask. I would love it if you know these, and it'd be great if you do. But I'm not testing you on if you know those, because I would design the test much differently if I was. So with that being said, we know it's 10. What do we got to do first? 10 minus 2 times 180. That's going to give us our total, right? Then once I get that total, what am I going to have to divide it by? I got to divide it by 10 because of the fact that it's a regular decagon. So there's 10 angles. So I'm going to divide it by those. This kind of brings us back to that formula that we had written down from the very beginning. Now, what is 8 times 180? 1440? Well, I don't think that's right. And then I'm going to take that and divide it by 10 because of the 10 angles. Nice thing about dividing something that ends in 0 by 10 144. Okay, what'd you do?
I didn't like how you find the areas of decagon and then like the angles together.
Oh,
Oh.
that's a lot. You should probably use this formula. The other thing you could do if you wanted to, if you're talking about an interior angle of a regular decagon, what you could do is find what one exterior angle would be. Is that what you're talking about?
No, I did like find the area and did like the 360 divided by 10.
So pause. Remember this, if you do what you just did, if I take 360 and I divide it by 10, that's going to tell you what one exterior angle is. So that 360 divided by 10 is going to be 36 degrees for an exterior angle. Now, every exterior angle is supplementary with an interior angle, right? So you could do 180 minus 36 to get 144 as the interior angle, which is another way of doing it. But you're saying what you did is once you got that, you then went out to divide them out to find out what each of the, maybe look back upon this video and think about your mistakes when that occurs on a test, because my God, that would take a long time. And, good for you.
You made a big mistake.
I don't know. You didn't add 42. Okay. I'm going to get in trouble for posting this video, I think. Okay. Find the measure of each exterior angle in a regular octagon. Come on, y'all. What do I got to do? 360 divided by 8. Well, that's nice. What do we get? 45. 45 degrees. That's nice. Okay. Everybody good? Are these front and back? Yeah. Another clear indication that I did not make this. I hate putting them front and back because it doesn't work as well for me. Okay. List the defining characteristics of each of the following quadrilaterals. Yes.
Sides are parallel to each other.
Okay. Opposite sides parallel. Good.
You have to know what the defining factors.
What's the angle for right?
Okay. So here's the thing. Parallelograms have 100 things. I'm going to write, so the defining characters, what makes it specifically a parallelogram is this. That does not mean that there aren't other characteristics that are a part of it. In the case of having opposite angles being congruent to each other, that is absolutely going to be the case, but that's because of the fact that the opposite sides are parallel and we can do the addition. We would say the consecutive angles are 180 degrees because they're parallel lines with a transversal that's cut. There's a lot of those things that come from the fact that opposite sides are parallel, but that's not what defines it. Does that make sense? Yes.
We do have to write all the information here that define like everything that defines the shape. Not obviously not like
On this, for this one specifically here, no. Because if you look at what we have underneath here, these three are specific ones that go along with different subversions of parallelograms. When we start talking about this for like a test itself, I'm not going to be asking you to. So for the video right now, Marley's currently walking into the classroom and dropping literally everything that's happening. So it's probably embarrassing as well. I'm currently recording this for Zoom just in case people want it. So this will be good. This is the best ever, guys. Okay, so what I'm going to say is this. There's not actually going to be a question on the test that asks you to list these. Just put it in the box. But there's going to be something that's going to ask you to use each of these. So it'll be something that says it's a parallelogram. Please mark all of the things that you know about it or something like that. So there's a possibility of that. I want to check to be positive of what is actually on the final before I give that to you. That's why we're starting to review today, so we have more days for it. So let's write just what we know about this so we can kind of go from there. What makes something a rectangle as a part of like that will definitely not get marked correct. Okay, what
four sides.
you can over there, there's a pile, I believe. Nope, because that would be a parallelogram.
You're allowed with four right angles.
You could even say a rectangle is a parallelogram. So I'm going to put a little symbol like that. We know that these tend to be that, but basically it's four right angles And if you did say quadrilateral with 4 right angles, it would have to be a rectangle because there's nothing else. Now, is it a long square? Yeah. But the problem is you have to define what a square is first, and then you'd have to define what long was as opposed to what it means for something to be a square, which makes it a little bit harder to do as opposed to just saying, hey, 4 right angles. Speaking of squares, it's a short rectangle. No, okay. So what you could say for something like this is that this is a rectangle
Where's side congruent parallelogram?
with 4 equal sides. Or congruent. You do whatever you'd like. Yeah. You could say 4 congruent sides to 4 congruent angles. That would be fine. Yeah, because there's nothing else. There's no way to make 4 congruent angles in a quadrilateral that they wouldn't all be 90 degrees. So I just did the rectangle part before because it is kind of a subset of that. What about a rhombus?
Oh, opposite angles are congruent.
That's also true of a parallelogram.
Angles.
It is a diamond. All the sides congruent. Thank you.
That's the same.
It is a square is a type of rhombus as well. Remember, it's the love child between the rhombus and the rectangle. It's a parallel with 4 congruent sides. Okay. Is a trapezoid a parallelogram?
Trapezoid.
It's quadrilateral.
Only one side of parallel.
Yep.
Only one pair of that works. Yeah, well, only one pair of parallel
42.
sides.
Yep. Only one pair of parallel sides. Why? I don't know. Guess good. How about now?
For the true or false, we just draw.
Which one? True or false? Oh, for a counterexample, sure. As long as you point out what part of it makes something like that. These are really easy ones, but they're also, just to be clear, if you have something here that you have a true or false and you do a counterexample, it'd be really easy to make something like this into a constructing because you'd have to explain somehow why. So if it was a constructing, Peter, for the way that you asked the question, what you'd want to do is drawing the picture. Please understand, from my perspective as a grader of these things, if you draw a diagram for me to look at in terms of what it is you're talking about, it's going to be a lot easier to understand it than if you paint me a word picture when it's talking about this. But at some point, write the thing that you want to point out that makes it a counterexample. So if it's because this has this and it shouldn't have this, then explain that. So like here, a square is a rectangle. Is that true? Yeah, 100%. This is true. You don't have to provide a counterexample if it's true. A rhombus is a square. So here's the thing that kind of sucks about this one. Can a rhombus be a square? Are all rhombuses squares? No. So the way that it should be written is all rhombuses are squares. But in this case, I would say that is false because it's not for all things. And then all you need to do is this. Not 90 degrees. So not square. Guys, you know what? I'd 100%. That would be a 5 out of 5 for constructing arguments. If you did that, I would give you a 5 out of 5, even though it is Tarzan speak when you're looking at that. Not 90 degrees, so not square.
No,
It's fine. Yeah, but like one way or another, kind of go through this.
no right.
A rectangle is a parallelogram. Done? Put it in a box. And then you got to drag your desk back. True. I am now. I clear that out. Feel much better. The last one is a parallelogram a trapezoid. Let's look at our definition. Quadrilateral, where only one pair of parallel sides is there. How many pairs do parallelograms have? Okay. No. False. Lies. Okay. only one pair parallel, two pairs parallel. Now, will I accept that as a 5 out of 5 for a constructing arguments? Yeah, I would. You're giving me the point in terms of what's going to be happening. I would say that as you roll into your second AP Prep math class, if you're starting to write things that are like this, you do need to start to write some complete-ish sentences to make sure that you explain what it is that's happening. But here it's good. It'll probably be me, but like when we're talking about the stuff that you're going to be doing for the algebra portion of it, some of it is going to be important to write the words because you'll find if you go further on in math, you will have to start to argue some of your points using.
I mean, our inability to write sim. We blame it on you.
Yeah, next year when you talk to me about what your class was like, you could say you hated your AP Prep geometry teacher and he was terrible. You know, just like you've thrown all of your Algebra 1 teachers under the bus. No, some people did not. Okay. Yes.
Would the following words be acceptable for a constructing argument? Prepare to copy. No right, no square. And
For what? Hold on. Oh, for B? Sure. You'd have to say false. And then you'd have to have a drawing.
for D is where is double parallel?
That is not gonna be okay. The fact that you couldn't complete the sentence out loud means there's no way that I would be able to accept it as any part of that. Okay. Everybody, Dante just died in front of the class. It was terrible. Okay, so here's what I want you to do.
Oh, no, we picked them up.
I also want you to know that if that actually occurred after making a joke like that, I would feel terrible. I would definitely not post this on the internet. Okay, so here's what I want us to do. Use from what? I take your phones. Okay, so what I want you guys to do, can you guys help me with how we find the measure of one of the angles here? Equals what number? 180. Yeah, because if you look at this, they specifically, okay, see that little symbol there? That's supposed to be a parallelogram. So when you take some things from an original in Microsoft Word where they actually had the symbol, and then it goes to Google symbols, this is what a parallelogram is supposed to look like. It's telling you it's a parallelogram. If you're not sure when you take the final about something like that, please ask. Does that say it's a parallelogram? I will tell you yes or no. Totally fine. But when we look at something like this, we know that consecutive angles are supplementary. So that would mean that I would add the two of these together, 9x plus 15 plus 6x plus 15. And what would it equal? 180. Now, let's find out x, and then we'll bring that back and figure out what we have to do with it. When we combine our x's, how many do we have?
Get rid of
15x for these two together. And then if I add 15 and 15 together, what do I have? 30 is equal to 180. I don't want to get rid of 15. Let's get rid of the 30 first. Because the math is super easy at that. This goes away. 15x equals 150. I bet you guys can tell me what x is without even thinking. If I divide them both by 15, x is going to equal 10. Now, they want the measure of angle W. Let's look at this for a second. We don't have anything from that, so what can we use? We could, but remember, opposite angles in a parallelogram are what? Congruent. So what I would use,
from the beginning.
I believe you as well, bro.
Prevent the truth.
I am nothing but an oppressor. Okay, so I'm glad that we have spoken of this here, guys. Thank you for being oppressed, and I'm glad to be a part of that. If you would, take that 10 right here and help me out. 90 plus 15.
W equal 105.
105 degrees, yep. Okay, do you guys have any questions about any of this? I'm currently going to stop sharing, and I'm going to end the recording